Hello everybody, in this video we're doing part 2 of the pi method. So if you did not watch part 1, I strongly suggest that you go back to part 1, even though it does not really say part 1. However, you should be able to find it, because it's the video that came out before this video. So in this video what we're going to cover is how to find how many elements are at least in two sets. So we're going to start with a problem. There are three sets, A, B, and C. A has 4 elements, B has 2 elements, and C has 21 elements. If there are 2 elements in A plus B, 1 element in B plus C, and 3 elements in A and C, and 1 element in A, B, and C, how many elements are in at least 2 of the sets? At first thought, because we're using pi, we may think that we'll just have to do alternating sums and differences, but instead starting with how many in 2 sets, which would give us 2 plus 1 plus 3 minus 1. And that would give us an answer of 5. However, this isn't actually right because we have overcounted yet again. Because in this case, this won't work if it's at least 2 of the sets. So this new method that we're going to go over works for at least 3 of the sets, 4 of the sets, and so on, as long as you just use logic. So we can just do this one problem and it can cover basically everything that we need to know with pi. So we see that there's 1 element in each in this. That 1 element in all of the sets. Let's just think about what how many times this element is counted. So it's counted once in the 2, it's counted once in the 1, and it's counted once in the 3. This means that it's counted 3 choose 1 times. And if you don't know what choose means, you really, to be honest, should go over that and maybe search that up, because then this video might be a little bit too advanced for you. But anyways, we've counted how many are in how many times the element is counted, and this is equal to 3. So if we've counted it 3 times, subtracting this once won't work. We'll have to subtract it twice in order to make this 3 equal to 1. So we have 2 plus 1 plus 3 minus 2 times 1. And this is our official answer. It is actually 4. So there are actually 4 elements in 2 of the sets. And we can check this by making a Venn diagram. I'm going to make these, that's a really bad Venn diagram. Like this. So let's say this is set A, this is set B, this is set B, and this is set C. And A has 4 elements. So let's go ahead by writing the 1 in the very middle. And since there are 2 elements in the intersection of A and B, then this thing in total has 2. So this side has to be 1. And we can keep doing the same thing, basically. So this is 0. There is 2 right here. So since we just want to find how many are in the intersections, we just have 1 plus 1 plus 2, which is 4. And that is our official answer, and that matches exactly with this. And if we write this in set form, this becomes number of elements in the intersection of A and B, plus the number of elements in the intersection of B and C, plus the number of elements in the intersection of A and C, minus 3 choose 1 minus 1 in parentheses, times the number of elements in the intersection of A, B, and C. And this ends up to be equal to 4. And you don't really have to memorize this formula. If you figure out the logic of pi, it should be really simple. And this problem is actually really simple, so you can easily do this with a, say, Venn diagram. But when you get to more complicated problems with more sets, like 4 or 5 sets, this becomes actually harder to do. So because we can't make a Venn diagram with 4 sets and 5 sets and so on, and if we can just do it by calculating it in our heads and writing down an expression and just solving it, it's much more simpler than making a lot of graphs and diagrams in order to calculate how many elements are in at least 2 sets, 3 sets, and so on. But anyways, I hope you enjoyed this video.